This is section 2.7, segment relationships. And what we're doing today is making proofs of segment relationships. The following proofs involve another special postulate called the segment addition postulate. We've actually seen the segment addition postulate. We saw it in section 1.2. And what it said was that you had this piece plus this piece is equal to the whole thing, the segment addition postulate. One of the things that it has to say is that they're collinear, just so it could actually be equal to the whole piece. On this statement, it says, if A and B or C are collinear, then the point B is the between, so not in the middle, it doesn't have to be a midpoint, of AC, if and only if. And this is important in mathematics. What that means is that you can write the reverse statement and it still be true. AB plus BC is equal to AC. And like I mentioned before, it's just this piece plus this piece is equal to the whole thing. A review of some properties. The reflexive property means that they look exactly the same on both sides of the congruent symbol or the equal sign. The symmetric property changes the order from AB is congruent to XX, YX, and it flips it around to XY is congruent to AB. The next one, the transitive property, I want to remind you that it has this special property right here, and then what you have is that the end results are equal to one another. So it's sort of like you eliminated that part, and you can say these ends. Number one. For number one, you have that AB is congruent to DE. That means that this piece right here is equal to this piece right here. And that DC is congruent to EF. That means this piece is equal to this piece. What you want to prove is that AC, the whole thing, is equal to DF, the whole thing. You always want to start with the given. So that is the reason that you can write things down, is because it's given to you. What was given to you is that the segment AB is congruent to the segment DE, and that the segment BC is congruent to the segment EF. Next, I'm going to change the symbol from congruency to equals. That means AB is equal to DE. Why? How can I change the symbol from congruence to equals? Is the congruency theorem. When you have these on your test, please don't take shortcuts. Write out everything that I write out. Don't try to put TH for theorem. Write out the word theorem. Don't put con for congruency. Make sure you write out the whole word. So since I can do that for this statement, I can also do it for this one. So BC is equal to EF. So I just change it from congruency to equals. The next thing that I can write is that AB plus BC is equal to AC. Why? What's the reason I can write that? Well, this piece plus this piece equals the whole thing. That's the segment addition postulate. That's the one I just mentioned earlier. Segment addition postulate. So if I can write it for the segment AC, I can also write it for the segment DF. DF is DE plus EF. I can also write that AB plus BC is equal to DF. Well, the only thing I really did was substitution. I took this statement right here, and instead of writing AC, I wrote DF. Why? Why was I able to do that? From here, I was given that AC was equal to DF. Where is that given? Okay, let me keep going. Now I can write that AC is equal to DF, because that's equal to AC. And this is also substitution. The last one, we have an equal sign and we need to make it a congruent sign. Once we make it a congruent sign, we have to say that it's the segment AC is congruent to the segment DF. What's the reason that we can change those from equals to congruence? The congruence theorem. Congruence is okay. Theorem. Number 2. So how we're supposed to fold this is this way. You have this segment right here and number 2 right behind it. We're going to close it like a book. I'll give you the opportunity to staple here and here in a few minutes. So number 2. It says that AC, that's this whole thing right here, is congruent to a BD, that's this whole thing right here. And I'm going to make the markings of congruent. And what you want to show is that AB, this part right here, AB, is congruent to DC, this one right here. So what do you always start with? The given. Why can you write the statement is because it was given to you. So you can write that the segment AC is congruent to the segment BD. From congruence to equals is the congruency theorem. Sometimes I say congruence, sometimes I say congruency. I think it's actually congruence, but congruency is okay. Theorem. Which says now that I can write AC is equal to BD. AB plus BC is equal to AC. So it says that this piece plus this piece is equal to the whole thing. Do you remember which postulate that is? Well, you're adding segments together is the segment addition postulate. For the test, please do not take shortcuts. Write it all out. Since I can say it about AC, I can also say it about BD. BC plus CD is equal to BD. Now I'm going to write AB plus BC is equal to BC plus CD. Why? What's the reason I can write that? AC is right here, and that equals BD. So instead of writing AC, I wrote this. And instead of writing BD, I wrote this. So the reason that I can do that is substitution. Now I want you to pay attention to this. I'm going to write it on purpose in the middle of these lines. Minus BC minus BC. So if I do that, I have AB is equal to CD. What could be the reason that I can write this step? It's called the subtraction property of equality. From the equal sign, we're going to go to the congruency. Do you remember what theorem that was? The congruence theorem. That makes this one, the segment AB is congruent to the segment CD. Number 3. Where do we usually start with? The given. Why can we write this information? Is because it's given to you. The information that was given is that B is the midpoint, and since I have very little space, I'm going to keep writing over here, of AC, the segment AC. They also tell us that D is the midpoint of the segment CE. And I'm going to put a semicolon just to save a little space. I also have that BC is equal to CD. All right, so what did they say? They said that this is a midpoint and this one's a midpoint. They also said that BC is equal to CD. So this one is equal to this one. What we're trying to prove is that AB, this segment right here, is equal to the segment DE, this one right here. So how do we start? We're going to start with AB is congruent to the segment BC. So I have that AB is congruent to BC. How do I know that? Well, it told us it was the midpoint, so we use the midpoint there. Since we can say that about the segment AC, then we can also say it about the segment CE, which would say the segment CD is congruent to the segment DE. Now I can write it. This AB is equal to BC. So I changed from the congruence to an equal sign. Do you remember what theorem that was? The congruence theorem. So if we can say it about the first statement, we can say it about the second statement. CD is equal to DE. Now I'm going to write that AB is equal to CD. How did I get there? By the transitive property. Okay, so what the transitive property did was eliminate one of those options. So let's take a look. So let me write it really small right here. I have AB is equal to BC, and I also had this statement right here. Let me rewrite it this way. DE is equal to CD. So they're saying that we use the transitive property, but I didn't use this one. I said that this is BC. Why can I do that? Because this one tells me that DE, no it doesn't. So we need to figure out why they told us that this is the transitive property, DE. And we use BC instead. BC. Oh, because they're equal right there. No, that's still not true. Okay, so what happened is that AC is equal to BC by this statement right here. But I'm not using this one. I'm actually using this one right here, which says that BC is equal to CD. And that's how we had the transitive property that we didn't write down, so I didn't remember how we used it. So that's what it was. We used this statement and this statement right here to show the transitive property. That means that these two are now equal. Now we can use that AB is equal to DE. Why? Why can we say that? It's because right here we have that CD is equal to DE. So we just use substitution. From an equal sign to a congruency sign is the congruence theorem. That means that we need to write that the segment AB is congruent to the segment DE. Number 4. What do we start with? The given. What is the reason that we can start with the given? Well, it was given to us, so we can write the statement that E is the midpoint of the segment AB. I'm going to use this symbol for the and. The segment CD, and I'm going to use a semicolon for the segment AB is congruent to the segment CD. Okay, so they're telling me that E is the midpoint of both of those lines. They also tell me that the whole segment AB is equal to the whole segment CD. Then the other thing they want me to prove is that this segment is equal to this segment. That's what they want us to prove. So let's start. If I've already given the midpoint, I can use the midpoint theorem to say that the little segments are equal to one another. That would be AE is congruent to the segment EB. The segment AE is congruent to the segment EB. And the segment CE is congruent to the segment ED. Now that I have congruency symbols, I can make them all equal. So I can say AE is equal to EB. I'm going to use a comma. CE is equal to ED. And this one right here, I can also say that AB is equal to CD. The thing that changes from congruence to equals is the congruence theorem. Next, I can write that AE plus EB is equal to AB. So just imagine in your test. I think that most of you can get all the way over here, but would you know to use this one on the next line? What is this? This is AE plus BE is equal to AB. That's this part plus this part is equal to the whole. This is the segment addition postulate. So if we can say it about the segment AB, we can also say it about the segment CD. What would it say? It says CE plus ED is equal to the whole segment CD. From here, we can write that AE plus EB is equal to CE plus ED. What we did is just substitution. So we have AB, which we write this instead of AB, is equal to CD. So instead of writing CD, we write this right here. And so that was substitution. AE is now plus AE equal to CE plus CE. What I want you to notice is this is the only part that changed. How could I change those two statements? Well, I have up here that EB is the same thing as AE, and that DE is the same thing as CE. So we just did substitution again. This is sort of like in algebra when we had like terms, like an x plus an x, then that would be 2x. But we have AE, so we're just going to call it AE. 2AE is equal to 2AE. Most students want to call this simplify, because that's what you usually called it in algebra. Algebra is like a direction or something that will indicate what to do, but it's not a property. The property is actually substitution. It cannot be addition property of equality because you're not adding the same thing to both sides. It's when you do the same thing to both sides that it's the properties of equality. So for example, you're going to divide by 2 here on both sides. Dividing by 2 on both sides is what makes this the division property of equality. I'm going to mention it again. Please don't take shortcuts. You have to write the whole thing. That means that AE now is equal to AE. I'm sorry, this was supposed to be C because this was CE. So this is supposed to be CE. That makes this one CE. From an equal sign to a congruency sign is the congruence theorem. That means that the segment AE is congruent to the segment CE. Number 5. It says that AE is equal to CE and that EB is congruent to ED. It does not say that they're congruent to one another. So what it wants you to prove is that AE plus EB is equal to CE plus ED. So the whole segment plus the whole segment. So what do we start with? The given. The given was that the segment AE is congruent to the segment CE, and that the segment EB is congruent to the segment ED. If we have that they're congruent, we can also say that they're equal. So AE is equal to CE. And EB is equal to ED. From congruent to equals, what is the theorem that lets me do that? Congruence theorem. AE plus EB is equal to AB. So what it says is that this piece plus this piece is equal to the whole thing. This piece plus this is equal to the whole thing. So what's the reason that I can write that? You're adding segments together. Segment, addition, postulate. CE plus ED is equal to CD. Now I can write AE plus EB is equal to CD. And what I did was substitution. It was substitution from this second equation. And what I did, instead of writing CE, I wrote AE. Instead of writing ED, I wrote EB. Now I can write AE plus EB is equal to CE plus ED by substitution. So instead of writing the whole thing CD, I wrote CE plus ED from this line right here. Number 6. Okay, so they tell me that all these segments are equal or congruent. So that's the reason I can write them, is that they were given. That the segment AB is congruent to the segment BC, and that the segment BC is congruent to the segment CD. I want you to box this right here. Does that help you identify the property? That is the transitive property. That means that I can go ahead and write that AB is congruent to the segment CD. I think all of y'all could get this on the test.
No way.
B is the midpoint of the segment AC, and C is the midpoint of BD. So we can use that information as given. So we can write that down. B is the midpoint of the segment AC, and C is the midpoint of BD, the segment DB. Okay, what you're trying to prove is that AC is equal to AB. The segment CD is congruent to the segment AB. All right, so how would you start? This one should tell you that you have that AB is congruent to the segment BC. And BC is congruent to the segment CD. How do I know? Well, AC says B is in the middle, so that means these two would have to be the same. On this one, it says that C is in the middle, making it the midpoint. That means these two segments have to be the same. So we use the definition of the midpoint, or the midpoint there. From here, can you identify this property? It's a transitive property. That means that the segment AB is congruent to the segment CD. But look how they want you to write it to end with. So they wrote that the segment CD is congruent to the segment AB. From here to here, what did I do? I just switched the order. That makes it the symmetric property.